Good morning. So today I'll be talking about the Chapter 5 Chemistry Review. So Chapter 5 is all about Introduction to Solutions and Aqueous Reactions. So first off, we talked about solutions, and solutions for any form of homogeneous mixture that consists of a solute and a solvent. And a solute was the minority component where the solvent was the majority component within the solution. And looking over to the concentration of a solution, you would usually calculate molarity. Molarity is the most common way of expressing the concentration of different solutions. And molarity is usually represented with a capital M, and it is the moles divided by the volume in liters. So, or moles equals the molarity times the volume. Moving on, we also have diluted and concentrated solutions. So a dilute solution has less amount of solvent, and a concentrate has a high amount of solvent. So dilute would technically have more water. Like, we could say one thing would be like if it had more water compared to like another solution, and that'll be a dilute. Where the concentrate would be more of like ammonium compared to something else. So now, moving on, we also have, to find a concentration of diluted solutions. In the dilution process, the volume of the solution changes, but the amount of solute remains constant. And normally we use the formula M1 times V1 equals M2 times V2, which is the molarity and the volume to find moles in the situation. Moving on, we also have like one sample way to kind of like solve this. If we have 400 milliliters of 0.6 moles of potassium chloride, if it was diluted to 920 milliliters, we can find the concentration of the solution by doing M1 times V1 equal to M2 times V2. Because we'd use the volume, the first volume that's given, times the first molarity that was given, would set that equal to the second volume that was given and the second molarity that was given. And we always make sure that our volume is usually in liters. Like normally, most of the time, our volume should be represented in liters. Now, moving on, we have the difference in solubility between sodium chloride and sugar. So for sodium chloride, Na has a positive charge and Cl has a negative, and it attracts the sodium within the situation. And then for sugar, it has an interaction. There's an interaction between water and the sugar. The interaction is very strong, and the bonds between the sugar molecules are weaker because the bonding begins to break apart and the sugars are pulled apart and moved into like access space, so they have weaker bonds. And then organic compounds do not conduct electricity because they contain carbon, and more ions equals more electricity. So if one compound has carbon in it and another doesn't, then we know that the one that doesn't have any carbon in it has electricity, because the ones with the organic compounds don't have any form of ions within them. So now moving on, we have the solubility of ionic compounds. So not all ionic compounds are soluble, but there are some exceptions. Like for rule number 1, all compounds containing group 1 elements are soluble. So that's things like potassium, sodium, just anything in that first column that's there. Then compounds containing nitrate and ammonium are always soluble, and all compounds containing acetate except silver acetate, so Ag and then C2H3O2. That's the only exception where it's not going to be soluble. And then most of the time you can tell if a situation, there's also some other exceptions, which is why some things can be soluble and which ones aren't, but it really just depends. So moving on, we have acids and bases. So acids are compounds that contain H plus ions in a solution, and bases have OH minus ions in a solution. And when acids and bases are mixed, water is produced within the acid-base reaction. So, water in the liquid state of the reaction. And we also have gas evolution reaction, which is the reaction in which gas is produced as a product and is regarded as gas evolution reaction. So, and usually reactive metals displace hydrogen from the acids to produce hydrogen gas within it. And we also have titration. Titration is a technique in which the concentration of an unknown solution is determined by using a known solution. And the indicator is used to note the completion of a reaction, the point at which indicators exhibit color, so the end point. So normally, like sometimes in the chemistry lab, we might have a solution that has like no color or a certain color, and then once it changes to like maybe a light faint pink color or just any type of pink color, that's how we know we've reached the end point. An equivalence point is when the equal moles of acid and equal moles of the base. So the acid and base are equal, right? And in acid-base titration, the moles of acid equals the moles of the base. And that is all for the Chapter 5 review.